Welcome back as we continue with our overview of mechanical seals. In this section, we shall discuss various drive methods and then review the basic principles. In the previous section, we saw that sealing is affected by two faces rubbing against each other. One face rotates against a stationary face or seat. The rotating face, however, has to be turned via the shaft. We therefore need some means of transmitting the motion of the shaft through to the flexible member. A common method of providing this power transmission is by using a pegged collar, fixed to the shaft with pins or grub screws. Dimples in this drive collar lock into the drive slots of the drive component. Variations on this design feature a peg drive into the seal retainer. Many bellows type seals use a slotted drive, whereby a slotted seal retainer is turned via a lugged drive ring. This drive ring is a tight fit onto the tail end of the bellows. Other drive methods include split clamps, pegged spring, or conical spring type. Let's review the basic principles so far discussed. We can now appreciate that any mechanical seal comprises a primary seal unit, that is, a rotating face, and a stationary seat or mating ring. However, a leak path exists between the rotating face and the shaft, so we have to have a secondary seal to stem this leakage. In this illustration, an O-ring is used as the secondary seal, and the whole seal is referred to as an O-ring seal. Secondary seals can also be in the form of a wedge, whereby the whole seal is referred to as a wedge seal. The third method of providing a secondary seal is to use a bellows. Such a seal is referred to as a bellows seal. In order to maintain surface contact of the primary seal faces, a type of spring is required. The spring device may be one large coil spring or a series of small coil springs. With rubber bellows type seals, a helical coil spring is generally used. Metal bellows design seals utilize either formed asymmetric type or edge welded type springs. Returning to the leak path areas, we learned that a tertiary seal is required to prevent a leakage around the stationary seat and the end housing. The most common methods of providing tertiary sealing are with O-rings, square or rectangular section seat rings, cup-mounted rings, and clamped seat with flat joints or gaskets, as on this double-sealed example. Lastly, we learnt that a drive method is necessary in order to rotate the seal face. Typical drive methods consist of a collar fixed with pins or grub screws onto the shaft. The collar may be dimpled or pegged in such a way as to locate into a driven component which contains the rotating seal element. Other drive methods include a slotted drive ring and drive sleeve arrangement, pegged spring, taper spring, and split clamp design. After the break, we shall discuss other important aspects concerning mechanical seals.